Over the last few years, artificial intelligence has changed the way users expect to interact with software. Instead of clicking through menus, filling out forms, or memorizing reports, users increasingly want to just ask a question and get an answer. Natural language has become the new user interface. But while AI makes software feel smarter, it also introduces serious challenges, especially when AI is connected to real business data. Letting users ask questions is easy. Letting them ask questions safely is not. In an enterprise application, AI should never decide access. When a user types "show me last month's sales numbers," the system must answer very differently depending on who the user is, what role they have, and what data they are allowed to see. An AI model alone cannot understand your authorization rules, respect role based access, apply business specific filters, enforce security boundaries reliably. That responsibility belongs to your application. So the real challenge becomes, how do we connect natural language prompts to structured, secure, role-aware database queries without letting AI overstep its boundaries? This is where Daemo comes in. Daemo is an AI-capable SDK designed specifically to bridge the gap between natural language input and secure role-aware application logic. Daemo helps by extracting intent and entities from chat prompts, producing structured, predictable query intents, allowing your application to remain in full control of authorization, role enforcement, and contextual parameters. In other words, Daemo understands what the user is asking. Your application decides whether the user is allowed to see it. This separation is what makes Daemo AI integration safe, auditable, and production ready. In this video, we'll walk through a chat-driven interface inside a Blazor server application where users query a SQL Server database using natural language, powered by Daemo for intent extraction and secured by ASP.NET Identity and role-based authorization. Let's start by giving a prompt to ChatGPT. I have an SQL Server database with HR-related tables, and I have defined models for these tables: employee table, application user table, leave request table, leave status table, department and job title tables. The goal is to use Blazor Server application with chat controller to query data from these tables in natural language. In this application, I'm using ASP.NET Identity for authentication. The roles table is seeded with admin, manager, and user roles. ChatGPT responded with some assumptions and guardrails to achieve it. For example, admin gets full access to all employee records, manager can access only employees with their own department, individual users can access only their own employee records. Importantly, AI layer should never determine access permissions. The controller is responsible for identifying users' role, translating it into database queries, interpreting intent, and applying authorization filters. For example, an admin prompt could be list all employees, while an individual user could ask, when did I join the company? Here, the AI extracts the intent while the backend enforces access control. Now, let's see how Daemo helps us achieve this goal. Now, let's navigate to a demo Blazor application in Visual Studio. This is a Blazor server hosted application using Entity Framework Core with standard pages for registration and password recovery. This is essentially a template Blazor server application. The main layout includes a navigation menu with authorized and unauthorized views. Pages like registration are accessible by admins. The navigation menu reflects user roles like admin, manager, and user. The database models include department, employee, job title, leave request, payroll tables. We'll use this to build a sample HR application. Now we navigate to app settings.json where we can give connection strings for the database connection. And then now we go to program.cs. In the program.cs, we have the application controller and the authentication state provider configured. This includes connection strings and role-based identity configuration. Controllers are mapped and the application is ready to run. And now we run the application. The application starts and I click login. I have preloaded the database with some synthetic data and registered some sample users. For example, tester of I has admin privileges. Logging in with this account gives access to registration page, add department page, add job title page, add role page. Here the admin can register new users. Next we will download the Daemo Nugget package. Go to manage Nugget packages, search for Daemo, and you will see the Daemo SDK. Daemo supports .NET 6 through .NET 10. The README includes a quick start template for integration in program.cs. After installation, Daemo adds dependencies like Newtonsoft JSON, gRPC, and Google Protobuf. You can see them here when you expand Daemo SDK. Right now the version is 0.2.3. Now we go to Daemo portal at app.daemo.ai. In the Daemo portal, you can sign in via Google or any email which can receive a magic link. Once signed in, you can create a new organization. Here I'll create a new organization. Demo. Once the organization is created, you can create a Daemo AI agent. I will give it a description of used for testing and agent name demo agent. Next is storage configuration for logs. You can use a MongoDB instance for custom storage, or you can use Daemo's built-in managed storage. Remember, once storage is created, it cannot be changed later. And now it gives the Daemo API key. You can store it securely. Now agent dashboard shows some tools. One is the Daemo Genie. It's a vibe coding helper tool. It can help us in writing functions. And then there's the query playground. You can test your agent and services here by bypassing login requirements, because you can configure the requirements here. And then the other one is deployment. Here we can find template code for curl, javascript, python, etc. for http API queries. We'll be using .NET to connect the Daemo API from our application. We go back to the organization level. In the settings, you can see that you can delete an organization there. In the usage tab, you can see usage of your agent and how much is left of your credits. Now we navigate back to our application. In the application, we configure the Daemo client in program.cs. We can use the template from documentation. We add service provider for the Daemo AI service, and we register Daemo functions. You can configure variables for Daemo agent endpoint and Daemo API key in app settings. And then we can provide our own LLM model or use Daemo's default LLM. We register the Daemo client as add singleton. Once we do that, we can create a functions folder in the project, and under this folder we can create a class Daemo AI service. Once we do that, we can include it in program.cs using the using statement. Once we are done with that, we can go to app settings.json, and then we can include the Daemo config in the LLM sections. You can also load these environment variables in the user secrets for local development, and for cloud deployments you can set these in the Azure App Service environment variable section, or if you're deploying on AWS IaaS, you can set the environment variables there. We provide the previously secured Daemo agent API key here. The gateway URL is engine.daemo.ai. And now we come back to program.cs and register our Daemo AI service class for the dependency injection. And now we run our application and observe its behavior. Returning to the dashboard, The demo service now appears under the AI agent with the description that we provided in the program.cs. Intelligent database assistant helping administration and employees retrieve meaningful data from tables using prompts. The service name displayed is the one assigned in program.cs. Next, we'll build functions to interact with the database. For example, for the admin role, we'll create a function to retrieve a list of all employees. We go back to the demo dashboard using the Daemo Genie, a developer-friendly assistant, to help us write this function. I prompt Daemo Genie choosing Gemini 3 Pro. Since Daemo is a developer-focused, it's a very developer-friendly tool. I provide Daemo Genie with a SQL Server database model, specifically the employees table, so the tool knows the schema. The developer acts as a human in the loop, ensuring that access control is enforced based on roles. I instruct Daemo Genie to generate a C# IEnumerable function to retrieve employee data. I copy the model of the employee table and provide the schema in the prompt. Daemo operates as a deterministic AI system, meaning it does not hallucinate and only accesses data through defined functions. It cannot generate any data externally. When a user sends a prompt, Daemo determines the appropriate function based on the user's role. Daemo Genie processes my prompt and then returns a C# code snippet for use with our application DB context. We see that Daemo Genie is generating some answers. We see that it has produced a IEnumerable code snippet to use in your application DB context. I copy it into a project. I use dependency injection for the application DB context. This function retrieves all records from the employee table. Now, we'll decorate this function with the Daemo function. The Daemo SDK provides the Daemo function attribute. This is where we provide the description of the function and define role permissions. The LLM accesses this description to determine the purpose of the function and the role-based access. Here, the developer has complete control over what data the user has permission to see. Now we run the application. Returning to the Daemo dashboard, under the service, the newly created function appears. Daemo automatically maps the function into the service with the employee object definition and return type via the API key we previously configured. Daemo also confirms that the service is online since we are running the application. Now let's go to the database. The database already contains synthetic employee data. We select star from employees table to retrieve all the records. The employee data has fields like first name, last name, date of birth, job title, department, date of joining, and address. And there are 60 rows of data. Coming back to testing the agent, we now configure the agent for the admin role and then execute the prompt get list of all employees. We see that the playground returned all the details of the employees. Now we test it with another user, create a new thread with the user manager, and then prompt list all employees. You see that Daemo has responded with an empty data set. And now we go to the logs and see what Daemo is doing in the background. The most important feature of Daemo is that it is fully transparent. It's not a black box. You can observe how it generates a JavaScript function call, executes the corresponding function with remote tool call, retrieves the data, converts it into natural language, and sends the response. Daemo does not have access to the entire database. It is allowed only to execute functions with strict role-based access control. You can also pass context parameters such as a username to the agent. Logs clearly show which user is making the request and their role.